Hello, my name is Robin Smart, and I'm honored to be your host for this Learning About Dementia series. As the education coordinator for the Alzheimer's Society Guelph Wellington, I truly know the value of learning about dementia if you, a family member, or anyone you know is affected. This series wouldn't be possible without the generous funding of the Guelph Community Foundation. Their support has allowed us to bring this series to you, and the Alzheimer's Society is sincerely grateful to the Guelph Community Foundation. We also extend thanks to the Village of Arbor Trails, who allowed us a location and provided refreshments for each of the sessions. But the biggest thanks goes to you for watching this DVD. There are 6 DVDs in the series, and although they build on each other, each one is designed to stand alone as well. We encourage you to watch all 6 in the series, but you can jump ahead to a topic that is of particular interest or really pertinent to you in your situation right now. After watching the DVDs, we encourage you to be in touch with our office for further education opportunities or to talk to one of our social workers. This DVD is about changes in people's brain function. When somebody has Alzheimer's disease or another dementia, what kind of physical changes are going on in the brain, and what does that mean for changes in people's function? We look at what we call the A's of dementia, and that helps us understand the changes in people's function and how they interact with their environment. I'm going to take you inside somebody's skull to the best of my ability, because what we find is that people with dementia look really good on the outside. Definitely for the first several years. They look just like anybody else. And so people have expectations that they will behave in a certain way. And therefore, what I want you to do is be able to see what you can't see on the outside, so you will understand better and remember. They don't have an obvious crutch to lean on or arm in a cast or something to cue you that they're having problems. So I'm going to take you inside the brain. So how the brain functions. This is a dramatic oversimplification, but I want to keep us all on the same page. Our brain hemispheres, basically, the left side is about language and analytical thinking, and the right side is more about spatial relations and attention. And I just want to show you a kind of cool picture. This was an illustration made showing the connectedness between the left and the right side. There are multiple connections. It's not that they work individually. They truly do work together. And Jan Christensen had this in Scientific American, and I thought it was a great way to understand that they are totally interconnected. So our brain weighs about 3 pounds approximately, 2% of our body mass. I can never relate to that, but this I can relate to. It takes 20% of our oxygen and our calories. That's why you want to keep a heart-smart diet. That's why you want to get physical exercise every day. You want to be pumping that oxygen up to your brain. It needs 20%. It has 100 billion neurons. That is a big number. Neurons are just a fancy way of saying brain cells. So 100 billion brain cells and 100 trillion connections or synapses. So here's a little diagram of a neuron. Now a brain cell certainly isn't a round thing that butts up against the next one side by side. A brain cell is actually, as you can see on the screen there, something that is rather extended and has branches or something that almost looks like a tree at the end, referred to as dendrites. So here's a more accurate picture for you. This is a 3-dimensional view. And what we're going to do is we're going to take a look at some of the things that happen in the brain. This right here, these are our healthy brain cells. This is a picture, unfortunately, of a beta-amyloid plaque. And I'm going to take you into an electron microscope image of that. And you can also have neurofibrillary tangles. So healthy cells, I don't know if you can see, there are little tiny electric impulses. This is what one looks like when it's sending a message. So what happens is, if you want to get a message from one brain cell to the next, is that it sends an electric impulse down these dendrites or down these tree branches at the end. This is the tree branch. There's the electric impulse. It's going to go down, and it has to jump over and get into the next cell. And the insert is a picture. It's the idea that it's sending the electric current down, and then it has to be picked up by the next cell and continue on its journey. So the synapse that we have 100 trillion of is the point of information transfer. It's when we get the message from one cell to the next. And they communicate with a variety of chemical transmitters. And the message has to go across this piece called the synaptic cleft. And I want you to sort of be picturing that the message has to jump from one cell to another, and there's a space between the cells, because I'm going to show you where things kind of go wrong. Now, this is a picture of all the different synapses on a single brain cell. This is from the Vancouver Coastal Health Institute. So this is a real picture of a real brain cell blowing up, blah, 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 many times. See all those little dots of light? Those are all synapses. So we want all our synapses firing. And we run into trouble when we get something called an amyloid plaque building up. We all have a protein called beta amyloid in our brains. But when this protein, unfortunately, it misprocesses. And little pieces of beta amyloid get snipped off when it misprocesses. And these little pieces that get snipped off are very sticky and very toxic. And they start floating around in between your brain cells. And they quite literally gum up the communication network, because the messages can't get from one brain cell across that synaptic cleft to the next brain cell so easily when there's these filaments floating around. Now, we know they're sticky, we know they're toxic, they're called oligomers, and they start bumping into each other, and then they start sticking together. And the larger they get and the more they bump into each other, the more they eventually form an insoluble plaque called a beta amyloid plaque. And this is a picture of a beta amyloid plaque from the University of Toronto. Now, when that's happening, that's gumming up the works between brain cells. But when we think about the brain cell itself, this is where we get something called a neurofibrillary tangle. And our brain cells are helped by a protein called tau. And tau maintains the structure of the brain cell and helps deliver nutrients. And tau is supposed to be lined up in beautiful straight lines, almost like railroad tracks. When the tau protein misprocesses, it's as if the ties for the railroad tracks come up. They get lifted, they start floating all over the place, and those railway ties, well, they just lift and tangle. And you end up with, and this does not look like railroad tracks, does it? You end up with what they call a neurofibrillary tangle. So what's really happening is the brain cell gets sick when it doesn't get its nutrients, and the structure starts to get out of whack, and it eventually dies. And so there's a period of illness and then a period of death of the brain cell, and when the brain cell dies, it shrinks away. So when the brain cell shrinks away, what you have is atrophy of the brain. You can lose up to about 25%. So the healthy brain picture on your left looks kind of plump and juicy. But you'll see that the brain that is diseased, that has lost a number of brain cells, there's a lot of shrinkage happening. You'll see that there are large spaces here. They don't butt up against each other anymore. They aren't close together anymore. So that's sort of an image of the shrinkage that can happen. What I want to do is I want to take you through this and show you three things on this set of MRI CT scans. There are three things to notice. One is how closely the brain comes to the skull. It really fills up all of your head on this side, which are pictures of the healthy brain. On the brain where there is unfortunately disease damage, you'll see there's a lot more room. The brain has really shrunken away from the skull. So you have shrinkage happening. I want to draw your attention to ventricles. Ventricles are little spaces, hollow spaces filled with cerebral spinal fluid that we have that we really need. We want our ventricles, but we want them to be nice and small, like these ventricles. That's a healthy brain. When you look at the brain that is diseased, look how large the ventricles become. They become very large. That tells us that the brain is literally shrinking from the outside in and from the inside out. The last thing I want to draw your attention to here is the white matter, or the density. When you look here, you see thick white matter. It's very clear. You can see how thick and strong the white matter is. Those are the healthy brains. When you look at the brain with disease, you'll see that it's much more shadowy. It's as if it's fading away. You can see the distinct difference. So that really helps us understand why people don't function the way they used to function, even though they look the same on the outside. Now I'm going to show you another picture. This again shows the brain atrophy, but from a different angle. It's looking down on top. I actually had somebody ask me once if that was a child's brain beside it. No, it just shows the percentage of shrinkage that can occur throughout a dementia process. And just here beside it is a normal brain's talking center up here. This is the normal brain's talking center. And then this is a brain of somebody with advanced Alzheimer's. See the dramatic difference. We can't see it on the surface, but we need to know what's happening under the surface so we know what steps to take. So here's the last brain slide for you. On the far side here, these are regions controlling hearing and understanding. So you can see this is the healthy brain, the area for understanding. There's been some dramatic shrinkage there. And this is hearing in the early, the middle, and the late stage. Again, dramatic shrinkage. The image in the center is all about your hippocampus. Has anybody heard the term hippocampus? Well, your hippocampus is pretty darned important because it's the piece that allows what we see and what we hear to go through. It has to go through the hippocampus to get into the cortex to go to long-term storage. So you want your hippocampus to be nice and small and healthy. Unfortunately, when you have dementia, your hippocampus can look like that big hole there. And that's why people can't retain new information, forget things that happened in the recent past. Not that they're not paying attention or they're not listening to you. It's that, my mom calls it Teflon brain, nothing sticks. Nothing sticks because the hippocampus has been damaged. And then at the very end here is the temper and personality region. And again, you have a healthy brain on the top, and you can see the dramatic differences. And that's why we have changes in people's behavior, their temper, their personality. So, the hippocampus and the cortex. I just mentioned the hippocampus, showed you a picture a second ago. All the information, all our senses, needs to go into the hippocampus. And it has to get into the cortex if it's going to be stored as a memory. And if the hippocampus is damaged, that's what prevents us from creating new memories. It's the gateway. I sometimes describe it as a rusty gate. It's as if sometimes you can push it open and get some information in, but as the disease progresses, it literally rusts shut. Now sometimes the oddest things get through, and people ask, how, why, how can that happen? And I suggest that it's through emotional mediation. If something is of significant emotional importance, sometimes it can act like oil on the hinges and get that gate open a little bit, sometimes to let things through. Your limbic system, deep in the center of the brain, the yellow part of the slide here, your limbic system is what connects behavior and memories. So this is your limbic system down here. And it also controls your daily functions. It's what helps you know day from night and keep your body organized. Circadian rhythms are controlled by your limbic system. So what I'm going to do is talk about the 7 A's now. And I'm going to go through these big A words, and I encourage you, you've got the handout, it's all written out. I encourage you not to worry about the A words. They're just the terminology, and I bring it to you so that you'll be familiar with it. You might have heard it before then if you go to a doctor's appointment or you're in a clinical setting. But take away the concepts, what those big A words really mean. So let's start with agnosia. And this, I think, relates to the question before the break about should somebody be reminded that they have a disease? Should they be able to retain and understand that information? When somebody has agnosia, unfortunately, there has been enough damage to the front lobes, the front part of the brain, that they lose insight. And it translates into loss of knowledge of illness. They don't know that they have a problem. They forget that they forget. They don't know that they don't know. They think they're just fine, thank you very much. So if there's a problem, it's you. It's your fault. I'm going to blame it on you because I'm A-OK. And so with agnosia, they often blame family members or people close to them, the people that are trying to help the most, and that can be frustrating for sure. So a person with agnosia tends to act on what their brain is telling them. They tend to lose their filters. Now, our filters do a couple of things for us. Our filters in the front lobes of our brain allow us to know what is socially correct from incorrect, what is polite from impolite, what is acceptable from unacceptable, appropriate from inappropriate. Call it your mother's voice if you want. And it's as if mom goes on vacation. And you have a hard time weeding out what is and isn't socially appropriate or normal. So if you have an idea, you'll probably just do it. If you have a thought, you're likely to just say it. Can slip out inadvertently. And you can say things that might be considered mean or hurtful or upsetting without appreciating that it truly hurts somebody's feelings. You can't appreciate the consequences of your actions. So you act in the moment. And I've got an example up here. Mr. D is unable to drink by himself, but he pushes the helper away saying, "There's nothing the matter with me, I'm perfectly fine." Well, you can substitute almost anything for the drink. I don't need your help bathing. I don't need your help dressing. I don't need your help brushing my teeth. I don't need your help eating. People think they're A-OK. I don't need your help with groceries or banking. I don't need your help in the yard. I don't need your help cooking. They think they're just fine when they're not, and they truly believe it. It's not denial. It's not that they just don't want to face a situation. They honestly think they're A-OK. Amnesia, everybody's heard this A word. This is a pretty common A word. If you ever watch the soap operas, you've heard of amnesia. Somebody somewhere always gets amnesia in a soap opera. But when you have dementia, it's not that way at all. When you get amnesia, you start to have memory loss. And you tend to lose your memories in the opposite order to which they're laid down. That means that you lose your most recent memories first, and then as time progresses, you tend to lose more and more of your own personal history as time goes on. You can think of your memory like an onion, maybe. And what the disease process does is it starts to peel away the layers of the onion one at a time. And each layer that it peels away is another layer of memory. So your oldest memories down at the center or the core of the onion, they're retained the longest. They're intact the longest. It's often a good place to go for conversation, those old intact memories. So people might not remember recent conversations, comments, questions. They often have access to the past. So 20, 30, 40 years ago, they can remember clear as a bell, but they can't tell you what they had for breakfast. They're not yanking your chain. They're just losing those layers of memory. And what it means is that they live right now in 2013, but they're accessing old information. So they're trying to function in the present with out-of-date data. They often have difficulties with sequencing. If they have amnesia, it's hard to remember what comes next, what happened before, what order do I do things in. So that can be a real challenge. So some of the memory changes that happen, people have short-term memory loss, and we can all relate to that. What happened earlier in the day, what happened last week, what happened a couple of weeks ago. Eventually, though, they will have long-term memory loss as well, so that eventually their own personal memories start to erode, or at least are inaccessible to them. It results in the person kind of, they're not living in the past, they're living in the current, but they only have access to their own past. So they're looking for things that are older and more familiar. Now, immediate memory is a little different. Immediate memory allows us to have conversation. So even if you have very impaired short-term memory, it is possible to have a conversation with somebody and enjoy that conversation, and then you go away and the person who has the memory impairment was able to talk to you in the moment but not retain that conversation. So when you come back the next day and say, well, did you do such and such? They say, what are you talking about? So don't get mixed up between immediate memory and short-term memory. Amnesia, the person with memory loss, people constantly asking where they are, what day it is, when are we going to go somewhere, that sort of thing. People with dementia, as I say, lose their memory, but it's not linear. We tend to think in linear terms, but they will have good days and bad days. Some days they remember a little more than other days. What often stays longer are procedural memories or overlearned memories. I worked in long-term care for 30 years before I came to the Alzheimer's Society. And I had people who lived on our special dementia units who didn't know the day of the week, didn't know where they were, didn't know their way around. But if I took them and put them at a piano bench, they could play beautifully. They didn't need music, they just played. That's like a procedural memory. People who can't find their way to the dining room but can tie their own shoes if they see it untied, because it's kind of built in like a body memory. Those procedural memories are spared much, much longer. Agnosia is a loss of recognition, and it occurs across all your senses, all 5 modalities. So you can have trouble understanding anything you see or hear or taste or feel or smell. I think the most common problem is that if you don't understand what your senses are sending you, you can get yourself into a misinterpretation situation, can even possibly be dangerous. I had a call when I'd only worked at the Society for a very short time, and it was a lady up north, and she said, my mother-in-law phoned me yesterday, and my mother-in-law said to me, there's the most annoying noise in here. It's driving me nuts. She said, I could hear over the phone that it was the smoke alarm. I said to her, Ma, that's the smoke alarm. And she said to me, yeah, it's a bit hazy in here. Ma, put the phone down, and go outside. Okay, happy ending to the story. The lady was actually burning a bagel in the toaster. And she went outside, she was safe. What happened is that the lady could see well enough, she could see that it was hazy, could see the smoke, she could hear well enough, she heard the smoke alarm going. We didn't talk on the phone about whether she could smell that charred, burnt toast smell or not, but I bet she could. But she didn't know what to do with the information. The process got broken down between I hear something and being able to recognize what it is and decide what to do about it. Or I see something, I understand that's smoke, where there's smoke, there's fire, that's dangerous, I've got to check this out. So what happens is people are unable to problem solve particularly well when they have trouble understanding and interpreting what their senses are sending them. Here's a little example for you. So the person starts to lose the ability to recognize people, and even themselves sometimes. In a mirror, they might not recognize themselves. They might think, who's that old person? Because if I'm losing my memory, and I have access to memories from, well, I'm only going back 50 years. If I go back 50 years, I don't look like I do now. There's no jowls, there's no wrinkles, there's no glasses, there's no gray in the hair. So when I look in the mirror, who on earth is that? Must be my mother. I think that looks like my mother. So they might have trouble recognizing other people or even sometimes themselves. They probably will have a hard time interpreting what their senses are sending them. So what do they do with things? If you don't really understand what an object is, how do you know what to do with it? There's a lady named Norma, and she has dementia. She lives in BC, and Norma tells the story about her end table at the end of her couch. And on her end table is a lamp and a telephone answering machine and a remote control for the television, a channel changer, and a cordless phone. When the phone rings, she hears it. She hears it. She knows it's a ringing. She actually even knows it's a phone. But she looks at those objects and she doesn't know which one she should pick up and talk into. So she struggles to recognize objects and what they're for. Here's an example. This one has to do with more grooming. But Mr. K was unable to recognize his grooming tools, and he used his toothbrush to comb his hair. Or Mrs. K looks in the mirror and thinks it's her mother. I gave you that example. Aphasia. Let's talk a little bit about aphasia for that lady. Aphasia is often associated with stroke, but it certainly happens in the dementias. And aphasia is a loss of language. Language is only two ways. It's comprehension and it's being able to articulate. So do I understand you and can I get my message out? It's incoming and outgoing. Those are really the only two paths. So people will have trouble with speech and comprehension. They have a lot of word finding trouble, struggling on the tip of their tongue, can't find the word they want. They may stop participating in conversation. They may really reduce their interactions with others because they have trouble with this. And they may revert to their first language. The gentleman earlier, when we were talking about languages, says that he speaks 2 languages and has done so from birth. What we often see are people who are born in one country, speak their native tongue for most of their life, emigrate to Canada, learn English, live in Canada for a number of years, speaking English well, and then they develop a dementia, some form of dementia. Their language starts to be impaired, their memory starts to be impaired, and they lose their English first, and they go back to speaking in their native tongue. Eventually, they then also have trouble in their own native tongue as well. So aphasia. People have trouble expressive, getting words out, or receptive understanding. So here's an example. Mr. G keeps calling things by the wrong name, or he can't remember names. And he'll say, pass me that thing, or let's go see, you know, that person, you know. Now, if you're an old married couple, maybe you do know and you can supply the word. But most of the time, it becomes a guessing game. Sometimes he can no longer speak in words that we easily understand. He often combines parts of words together in sort of a word salad. So sometimes combining words together. That's aphasia. And apraxia is the difficulty to initiate a purposeful movement. Now, I think you've got enough room in this room to try this. I'm going to invite you to all put your right leg out. I'm going to do it with you. I'm going to invite you to put your right leg out and circle your ankle around to the right. And then take your right hand and make a 6 in the air with your right hand. Okay, what happened to your ankle while you did that? Did anybody's ankle go the other way? Rest your arms, rest your ankles, flip your other ankle, make yourself balanced. That's not really apraxia, but for just a moment, relax, rest when you're ready. You asked your body to do something, and it didn't do what you asked it, and that's apraxia. You want your body to reach out and take a drink. So my brain is saying, you're thirsty, it's warm and dry in here, reach out and take a drink, but my arm doesn't do the action. So apraxia is trouble getting started doing something. You might have difficulty directing body parts to do familiar tasks. You may have difficulty understanding directions. So you say to somebody, could you please put your arm up? And they put it down. And you think, well, aren't you not cooperative? It doesn't have to do with cooperation. It has to do with misunderstanding directions, left, right, up, down, back, forth, that sort of thing. So with apraxia, the person loses the ability for purposeful movement and the ability to plan and sequence a set of steps. Now, I've seen folks who sometimes get dressed and they end up with their underwear over their clothing. That's apraxia. I gave you the example about how you know that you want to put your pants on before your shoes, usually. That's usually the order. People lose the ability to do things in a particular order. Here's the example. Mrs. H is no longer able to dress herself. Now, she's still able to respond to cues to don or put on a particular item, so she just needs to be reminded and told. But she can't just pick up the house coat and put it on. But if you hold it up and encourage her what to do, then she'll be able to do it. So people need a lot more cueing and a lot more help. And apathy, loss of drive. Apathy is where people don't initiate to do activities and where there's little or no emotional response. You tend to get some flat affect. And so with apathy, the people don't initiate conversation or take part in their favorite activities anymore. The example here is about a lady who just sits in her chair all day long. And she just sits and stares. She sometimes watches TV. And if the program is over and it goes to, you know, that snowy air at the end sometimes on a program, she'd sit there and watch the snowy air. So they don't initiate without a lot of prompting and cueing and assistance. Altered perception, here's another A for you. It's misinterpreting sensory information. Now, you might not be able to see it because we dimmed the lights for you, but one of the reasons we had this section of the room blocked off is that there are a lot of cords here. It's on the floor. If I had altered perception, I might look at cords on the floor and think they're snakes. Or I might look at a coat hanging on a hanger in a closet and think there's a person standing there. So there is a stimulus. I'm actually seeing something, but I'm misinterpreting what I'm seeing. You can have all sorts of, we're going to talk about delusions, illusions, delusions from this. I want to mention the loss of color acuity and depth perception that comes with this. When you lose color acuity, unless you have high contrast between things, it's almost impossible to see them. Yellow on white is invisible. Red on purple, invisible. If you went into a room and you had dementia and they had a beige carpet and a cream-colored walls and mushroom cushions, how would you know where to sit down? It would all just blend together. So you do need things with good contrast. And that loss of depth perception means that you're often very hesitant to move from one color to another because it looks like there's a hole or a drop down, or it looks like a large step, or it makes it hard when you're outside and the concrete and the curb and the road are all the same color. Where do I lift my foot? Where do I step down? So you need good assistance to navigate your way through the environment. With altered perception, the person also loses their ability to, peripheral vision is damaged. So you have less ability to see peripherally. And that happens as the disease progresses, certainly at the side, but up and down as well. What do you see? You stop seeing in 3 dimensions when you lose depth perception. So if you look into a bathtub, it may look like it goes on for umpteen feet down. Or if you look at a television, it may look right in the room, becomes 2-dimensional. You can also misinterpret. This is an example. Mr. W mistakes the worker kneeling at the bedside to pick something up for his dog and pats the woman, calling her Rover. So just a misinterpretation. That is actually a true story. That example was taken from my grandfather and my mother because we took care of my grandfather at home. And yes, reached down and patted my mother who got down to get something and called her by the dog's name. Penny. Penny was the dog. So what contributes to an altered perception? Well, progressive decreases in your ability to sort out sensory information. Your inability, unfortunately, to connect sensations with matching meanings. That's the agnosia. So you get a sensation, but how do you interpret it? What does it mean? What should you do about it? And does altered perception contribute to illusions, delusions, and hallucinations? So let's look at those a little bit. A delusion is thinking and firmly believing that something that isn't true is true. You're absolutely 125% convinced of the truth of your belief, even though there is no basis in reality for it. So that's a delusion. Often there are common delusions associated with dementia. My partner is having an affair is a common one, even if the partner is deceased. People are after me, there's a paranoia component to it, or people are stealing my, and substitute the word of choice. My money, my wallet, my flowers, my aspirin, you name it. Whatever that person is concerned about, they often think things are being stolen. Unfortunately, you can't talk somebody out of a delusion. That's not very successful. What you can do is, and we'll look at this in one of the other lectures though, is to hear the person, sympathize, and try to move on from there. A hallucination, on the other hand, is something that could happen across any of the 5 senses. And it's something that has no basis in reality, but the person firmly believes they are hearing, feeling, seeing, tasting, touching something. I had a lady that I worked with that had auditory hallucinations, and she was convinced that she was picking up gospel radio on her fillings in her teeth because she heard music all the time. She heard gospel music in her head. There was no music anywhere. And yes, we took her to the dentist and got her fillings checked. But that's just an example of an auditory hallucination. People often see things that nobody else sees, and it's not seeing a cord and thinking it's a snake. There's absolutely nothing there to be misinterpreted. They just see things. And attentional deficits are something that you'll run up against. People have trouble focusing and concentrating. They're easily distracted. The flip side of that is that often they can't be encouraged to a new topic. Sometimes they get stuck. So they either flip around and can't focus and can't concentrate and can't stick with something, or they perseverate, which is a big word for they get stuck on something. And they're just doing the same motion or the same action over and over and over. They can't move on to something new. So this altered processing, this inability to sort out with our brain that has damage, different sensations that are coming into it, means that everything is slowed down. Our ability to process is severely slowed down. So what we do when we have information come in is our brain says, okay, what is this? Is this something I'm seeing or hearing or feeling or touching or tasting? And it starts to process that. So you've got incoming information, your brain starts to process it. And whether you know it or not, every memory you have has an emotion attached. So when the brain starts to process it, it says, now, what emotion do I feel about this? And then it says, okay, I'm going to evaluate the situation and I'm going to do something. I'm going to have some sort of demonstrated behavior. That is the process that every brain goes through, whether it's a healthy brain or a brain that has dementia. That's how our brains work. Incoming information, it's processed, we attach an emotion to it, we then decide what our evaluation is, and then we do something based on our evaluation. Unfortunately, when you have a dementia, the piece where the processing gets, that's the second piece, incoming information, it's the processing piece. That's where all the misinterpretation happens. So you can end up with an inappropriate emotion attached to it, an inappropriate evaluation, and a demonstrated behavior that you would never have had in the past because it's the processing piece that gets damaged. Now, I gave you a bunch of medical stuff, and we are so done with the medical stuff. You're all going, that part's over. The reason I gave you that medical stuff is so you had some knowledge about what's happening. But this is the piece that you need carried forward, and it's the non-medical definition of dementia. Dementia is a shift in the way a person experiences the world around them. Many people say that. I'm attributing it to Dr. Alan Power. He's written a book, Dementia Beyond Drugs. He was our guest speaker at Allies last year. So non-medical definition of dementia, a shift in the way a person experiences the world around them. It's due to all those brain changes. So people with dementia are engaging in the world as they view it now, as they interpret it and process it, not as we do, but as their damaged brain does. And what does that really mean for us? Well, you have to come back next Tuesday to find out, because that's as far as we're going to take you today. So I want to thank you again for being here this afternoon. I am going to open the floor to questions and comments. Don't forget that you can contact us for any of our free services. It's on the back of all those brochures I gave you. I hope that I see you next week. When you come back, do bring the green bags, because we'll put more information into those bags for you.